Now let's move to the last problem in rectilinear motion, and that is saying that a freighter is moving at a speed of 8 knots. So a ship is moving at a speed of 8 knots. So now you are given with a units of speed called knots, right? So 1 knot is defined as 1 nautical mile, which is different from the land mile or land measured mile, 1 nautical mile per hour, right? So it has the dimensions of distance divided by time, but the distance is measured in nautical miles and time is measured in hours, right? So what nautical mile is, that it is actually the conversion factor is this, that it is equal to 6076 feet, right? Or in other unit conversions, 1 nautical mile is equal to 1.1508 land measured mile, or the normal mile which we use in the US units, right? Nautical mile is the unit of distance which is generally used in marine sciences, in the calculations of ship trajectories, their motions. It is also used by pilots or astronauts. The main difference between nautical mile and mile is that nautical mile takes care of the Earth's curvature also, or the round shape of Earth also. So when you are talking about like distances of hundreds of miles or thousands of miles, then obviously the shape of Earth will also take its role, right? And then this unit actually is introduced for large distances. 1 nautical mile is defined as, actually 1 nautical mile is equal to 1 minute or 1/60th of 1/60th of a degree of latitude along any line of longitude, For example, we know that on Earth we have these hypothetical lines. For example, latitude is like this, that these are the lines. The middle line is called equator, where latitude is 0 degree, and then as you go towards pole, the latitude becomes 90 degree, right? Similarly, we have lines for like longitude like this, right? So these are longitude lines, and longitude is 0 degree right here, and then it is 180 degree here, and at equator it is 90 degree, right? So we know that we can divide degree into minutes. 60 minute is equal to 1 degree, right? Similarly, minutes can be divided into seconds. These are not minutes and seconds which we use for time. They are the subdivisions of an degree or subdivisions of an angle, right? So when I say 1/60th of a degree, it is also sometimes called as 1 minute, right? 1 minute, or sometimes denoted as like 1 and a dash on it. 1 minute means 1/60 of a degree, right? Similarly, 1 minute can be also written as 60 seconds, right? So a nautical mile is defined as 1/60 or 1 minute of latitude along any line of longitude, right? So imagine that you cut the Earth like this, right? And then you are looking at one half and you are looking at its circumference, right? So that circumference is actually made of all 360 degrees. So if you travel on that surface, on that circumference, by 1 minute or 1/60th of a degree in latitude along any of these lines of longitude, right? So for example, you move from equator to North Pole by a difference of 1/60th of latitude, that distance will be 1 nautical mile. And since that distance will be like a curved distance, slightly curved distance, it will be different from the regular mile which we use on land, right? So therefore, it has a conversion of like 1.1508 land measured miles, right? Now, one question you might think is that why we need this nautical mile, why we can't use the simple mile for these applications also, if we have the conversion. Actually, one obvious reason is that whenever we have the nautical maps, the maps which the mariners use to navigate in oceans, those maps actually have the lat long on it already, right? So it's like converting a whole globe into a two-dimensional map having lat long readings on it. So it is more convenient for them to talk in terms of nautical miles because lat long is also on the same map, right? Compared to the linear mile or land measured mile. So in many applications, measuring distance in nautical mile is more convenient, and this particular problem is in that particular unit. Actually, when you divide 1 nautical mile with 1 hour, you get a speed unit called knots, right? So a ship is moving at a speed of 8 knots when its engine are suddenly stopped, and if it takes 10 minutes for the freighter to reduce its speed to 4 knots, so after 10 minutes of engine stop, the speed reduced to half. From 8 knot to it reduced to 4 knot. Determine and plot the S in nautical miles moved by the ship and its speed in knots as a function of time t during this interval. So again, S versus t needs to be determined, V versus t needs to be determined, and because of that sudden stopping of engines, the deceleration of ship is proportional to square of its speed. So A is minus k v square. So A is related to V or is given in terms of V, but not a very simple kind of a function. It is minus some constant k multiplied by V square, right? So if it was moving with a very high speed, when the engine suddenly stopped, it should experience a very high retarding acceleration, right, compared to if it was going slowly. So you can imagine how that relationship would physically mean also for that ship. So let's start the solution now. Given is the initial velocity is 8, right? So initial velocity at t equal to 0. So at t equal to 0, v is equal to v naught, which is equal to 8 knots, right? Knots mean nautical mile per hour. And second information given is that A is equal to minus k times v square. So acceleration is given as a function of velocity. So which means that it is a problem of case C. Case C, if you remember, was that case where acceleration is given as a function of velocity. And in case C, the solution technique which should come in your mind straight away is that you should use or start with equation 2. But let me quickly write to determine. To determine is simply V versus t and S versus t, right? So solution will actually start by applying equation 2. Equation 2 is the definition of acceleration actually. So A is equal to dv by dt, right? Now acceleration is given as a function of velocity, which means we should take A on the other side where dv is there, right? So we can write it in this form, dt is equal to 1 over A dv. Now we know that acceleration is given as a function of velocity. So let's apply the limits and integral equations, it becomes from 0 to some t, and the limits of v will be from v naught, which is 8, to some value of v. So it should start from 8 to t, right? So again here when I write these limits, I decided to make it a definite integral by using the initial conditions and applying the right limits. We will use that information, and that information was actually at t equal to 4, v was 4 knots. Yeah, I should actually write it here in the given part also, but we will use that information at some later stage, right? We can actually use this information to calculate this k also. It actually says if it takes 10 minutes for freighter to reduce, so 10 minutes, actually the units of time in this whole problem should be hours, because when you say knots as the unit of velocity, by default you are saying hours as the units of time. So it should be actually 10 minutes, you are right, but we should convert it into hours in order to use it in any formula. So 1/6 hour, right? But currently the information which I encircle, I am not using it, but at later stage it will be required, right? Let's evaluate that integral and determine what we get. For example, here we will be getting 0 to t dt is equal to from 8 to v 1 over minus kv square dv, right? If I evaluate that integral, I know that it will become minus 1 over k, and integral of 1 over v square is actually minus 1 over v, right? So it will become minus 1 over v, and the limits will be from 8 to v, right? Everyone clear that integral of 1 over x square dx is equal to 1 over x, right? Minus 1 over x, right? So I apply that on the left hand side, it becomes simply t, right? And I can take that k on the other side also, so it becomes kt. Let's take minus also on the other side, so minus kt, and this will become minus 1 over v plus 1 over 8, right? So when you have upper minus lower, then this sign will become plus, right? So this will be actually my equation relating v and t, right? So the first thing to determine was v versus t, and that can be determined readily, right? But again, it is not only between v and t, k is also appearing in the equation, which is still unknown. We were given an additional information which can be used to determine exactly the value of k, unlike the last problem where k remained unknown throughout the equation, right? But here we were given another, you can say, pair of v and t, which we can put in this equation to determine exactly what k is, right? So rearranging that actually will give me v is equal to 8 over 1 plus 8 kt, right? So if I rearrange that equation at the bottom, I can write v as a function of time, and that equation will become v is equal to 8 over 1 plus 8 kt, right? So now let's apply that information, that at t is equal to 10 minutes, v become 4 knots, right, from 8 to 4. 10 minute actually mean 1/6 hour, right? So the units of time in this problem will be hours because velocity is in knots. So therefore, when I put 4 here, 4 knots is equal to 8 over 1 plus 8 multiplied by t will be 1/6 multiplied by k, right? So this actually application of this additional information can help me in determining what k is, and k will be actually, when you put the numbers in that, and k will be 3/4, right? So you can see it will cancel out, you can take k on the other side and separate k, it will become 3 by 4. Now what do you think, what will be the units of k? K is a constant. What do you think its units will be? A is given as minus k v square, right? So k is a quantity relating acceleration with velocity square. So which means if the units of A is, for example, if I talk in terms of the dimensions, acceleration is actually length divided by time square, right? And on this side you have the dimensions of k times length divided by time velocity, and that is whole square, right? So actually if you work that out, you will see that the dimensions of this is actually dimensions of k. So let's call it, for example, like this. So dimensions of k will come out to be what? Length raised to power minus 1, or 1 over miles in this case, because for example t raised to power minus 2 will cancel out from here. You will have L square, you have L here, you take L on the other side, you get dimensions of k as L raised to power minus 1 or 1 over mile in this problem, right? So actually I should write 3 over 4 nautical miles raised to power minus 1, something like this, right? So k is determined, which means the velocity equation can again be written only as a function of time now. So again let's put k there, it will become v is equal to 8 over 1 plus 8 multiplied by 3 by 4 t, 8 kt, and this will give you 8 over 1 plus 6t, right? So that is actually your final equation, which you can plot also, because one of the thing to determine in this problem is to plot velocity versus time, right? So you can put different values of t to plot values of velocity. Finally, we have to determine displacement as a function of time, which means we need to integrate it with respect to time one more time, or in other words applying equation 1. Equation 1 is actually ds is equal to v dt. One thing I would like to mention here is that while integrating this acceleration for the first time, I opted for making a definite integral. You could have made an indefinite integral also, and then later on use this information at the top to calculate the constant of integration. Just like we did in the last case, you should be able to get exactly the same expression, right? So, but I just followed one of the two approaches, a simpler one. So let's evaluate this integral. V is already a function of time, so we can evaluate it from 0 to s, from 0 to t, right? This will become 8 over 1 plus 6t dt from 0 to t, right? So on the left hand side we will be having s, but on the right hand side we have something in the denominator, the variable is in the denominator. So we can, for example, in this case we can use this equation, looking at the form of that integral, that the variable is appearing in the denominator and there is a constant quantity added to that. So it is actually of the form like this, 1 over a plus bx, or for example we can call it like ax plus b, and it is being integrated with respect to x. The integral of this is actually log of the same ax plus b, but the derivative of the angle, the derivative of that whole thing need to be divided, so it will actually be small a at the denominator. So we can use this information and applying it to this case here, it will become 8 will come out from the integral. It will become log of 1 plus 6t, and 6 need to be divided at the bottom. On the left hand side it will simply be s, right, when you apply the limits from 0 to t. But on the right hand side you still need to apply the limits 0 to t, right. So let's apply the limits now. It will become s is equal to 4 by 3 log of 1 plus 6t. So when you put t equal to t and then also t equal to 0, you will see log of 1 will be 0, and then you will simply be getting, this will be cancelled out, this will become 4, this cancel with 3. So therefore 4 over 3 log of 1 plus 6t. So this simple equation is actually relating your displacement versus time, right. So the one of the question was how much distance was traveled in a particular time, right. So now this equation can be used to answer that question. For example, it was asked that what will be the value of distance when t was 10 minutes, right. Actually, if you go back to the statement, it says that determine and plot the distance in nautical miles moved by the ship and its speed in knots as a function of time during this interval, right. So if I want to determine how much distance is actually covered in the first 10 minutes, I should first convert t into hours. It will be 1 by 6 hour, right, and simply put t in that. It will become s is equal to 4 by 3 log of 1 plus 6 into 1 over 6. It will become log of 2, and you can evaluate that. It will come out to be 0.924 nautical miles, right, nautical miles. Similarly, if I go back, I can write the units of this thing, whole thing will be actually knots, right. Finally, if I plot that equation v as a function of time, you can see that this is the equation for 8 over 1 plus 6t. So v is equal to 8 over 1 plus 6t, and similarly this is the distance s, that is 4 by 3 log of 1 plus 6t, right.